What's up with AI in development? Why am I asking this? Well, Q3 2024, we have Sundar Pichai at Google saying more than 25% of new code is being generated by AI. The future is already here. Hooray! And yet, if we look at about the same point in time, 2025, when everything's got a lot more advanced and we're much further into the future, we have this report which has been very much a lot of headlines shared around in lots of ways by lots of people. 95% of organizations are getting zero return on their AI projects. Or to put it another way, only 5% of AI projects succeed. So what's up with that? What you do see is there's still a lot of hype around, but there's increasingly a lot of skepticism now as well about what AI can achieve and how. Same time though, everybody is using ChatGPT or Claude or Gemini or whatever all the time at work, out of work to achieve things. So there's a lot of it going around. What is going on? Why all these mixed signals? There's a couple of things I wanted to clear up. So to cut through the hype, extreme positions on both sides are often misleading. Everybody's kind of pushing an agenda here. If we look on one side, there are organizations, I'm not saying this about Google or any organizations in particular, but there's a lot of boosterism, I think. A lot of people saying, well, we are generating X% of code by AI because it sounds really good on the face of it. We'll come back to that. But these are sometimes misleading. So, for instance, some companies will count effectively autocomplete. So when you're using a code assistant to generate, an obvious sort of form of a loop or an obvious body of a function, and they'll call that AI generated code when really it wasn't an unsupervised agent writing the code. It was a human hitting tab on the keyboard and pressing approve when it had the right thing. It's quite a different model from the AI is out there writing code on its own for us. The other side, though, is the pessimism isn't all quite accurate either. A lot of headlines cited this 5% of projects succeed. Actually, the report, which is very interesting and I recommend reading, from the Nanda project at MIT, is actually across multiple industries. They specifically single out the tech segment as doing better. So, we know we're not perfect in tech. We know there's a lot of work to do, but actually, that kind of pessimistic headline is kind of clickbait. It's not quite true for software organizations. However, there are still issues. I want to run very briefly, through the story so far. So AI moves quickly, terminology changes all the time. This is, I believe, correct at the current time. Whenever anyone talks about AI at the moment, they're talking about LLMs or large language models. These are the current generation of technologies generally based on transformer architecture, not robots in disguise, but a kind of neural network. And using those, we're able to build code assistants. So the first wave of smart autocomplete in IDEs came from LLMs. This was the ability to, say, generate basic functions just from a name or just from a comment. It's pretty cool. Increases your development velocity somewhat. You can churn out more stuff, but it's only kind of one shot. The next evolution here is chat. So this is the ability to ask questions, have a dialogue with an AI. ChatGPT was obviously the first most famous one of these. If you want to do coding work with one of these, you need to copy and paste code in and out of it or otherwise upload files, which is quite cumbersome. It doesn't integrate directly with your development practices. So various IDEs have grown abilities to chat more effectively about the code you're working on within them. But even that is still a step off what the tools are now starting to do, which is agentic workflows or work done by agents. And an agent is an AI entity that interacts with the world using tools to solve a problem. So you can delegate it some work and it will use tools like editing files and running other programs in order to solve the problem you set it. When people talk about these, they often use metaphors like it's like a junior developer, or it's like an enthusiastic intern who's read the whole internet. And what they really mean by this is they're not magic. You have to manage them carefully. They don't have any common sense often, and you need to steer them on the right track if you want to get a good outcome. I'm going to touch on where do these projects to get AI used in organizations go wrong, and I would say there's a couple of places. So the first one is on, are you solving the right problem? And I think there's quite an obvious thing here. I've talked to other people in the debugging space, and they all agree this is a bit confusing. We know that thousands of lines per day of code is not an effective measure of an engineer. We already know that. We've known that for years. Most development work, most of the value you're getting out of experienced engineers is in understanding code. So maybe that they've just written, maybe someone else wrote, maybe code that's from another decade, but there's a need to understand and debug it now. And then kind of more specifically in debugging really complex issues. So issues that have been reported by customers where you might not have direct access to a reproducer, intermittent defects in your test system, etc., etc. The point is that the thing that's consuming engineers' energy and time is not mostly typing in the code. So are we solving the right problems when we make increasingly capable AIs to generate more of the stuff? By the way, this is my finger in the air estimate. We've not done any research onto this one, but I reckon maybe 15% of your typical developer's time in an enterprise organization is actually spent generating new code. And that's the thing which coding agents are most enthusiastically benchmarked on all of the time. It's a bit weird. The other side of why I think AI projects often don't succeed very well is more of a technical one, which is, again, it comes back to LLMs and how intelligent are they? How magic are they? I would say colloquially that how smart an agent is limited by the data it has access to. And the data it has access to is pre-trained data. So the data it pulled in from the internet and the reinforcement learning that was done on top of that in order to teach it how to use that data well, how to perform tasks and reasoning, etc. And then the other side is working data from your system. So stuff that couldn't be trained on by your model provider. Things like your source code, stuff in your issue tracker, context provided by a developer about what they want and why. All of that needs to be as good as it can be if you want to get the best out of your AI and out of your agent. Just an aside, I've said they won't be pre-trained on your code base or your workflow. If you're doing fine-tuning within your enterprise, then they might be. That's potentially really powerful. That's a way of modifying a off-the-shelf LLM to do better at specific work that matters to you. I suspect we'll see that becoming more common as time goes on, but the ordinary state of things is that you're using an off-the-shelf LLM and it doesn't natively know anything about your code base, which means it needs to be read in to what we call the context window or working memory of the LLM. And that is basically a limited storage they can use for current thinking. So new information they've got, deductions they've made, information that's come from the users. The tricky thing with this is because it's of a finite size, you cannot fit everything. So you cannot just put an enterprise code base or even probably some hobbyist code bases all into the context window of an LLM and hope to get good results. Chances are it won't fit at all. But even if you could fit it, they also get distracted by irrelevant information. You really only want to give them high quality context about the problem space. So by high quality, I mean detailed, rich information that's actually relevant to the problem. If you don't have that, then you either get distracted by irrelevant information or you see what are colloquially called hallucinations. What do we mean by hallucination? Well, I got an example by taking ChatGPT and disabling its ability to search the internet. So we asked it who won the Paris Marathon for dogs in 2012. Well, it was won by a mixed breed dog called Lola, ran alongside her owner. It's actually called the Marathon du Chien. And hang on, this all sounds very detailed, but is it true? As far as I can tell, no. If somebody actually, if somebody knows about this and it's a real thing, then please tell me, because I can't find any evidence this exists. ChatGPT, though, was convinced. I'd taken away its access to good context, and in the absence of that, it came up with an answer which sounded plausible and fluent and detailed, but wasn't actually true in the sense that we would care about. It was a good answer in everything except for not really being an answer. So with LLMs, you always have to, because of these limitations, you always have to provide them the best context that you can into their working memory to help them think. And you have to verify their conclusions if you want to have confidence in what they say back to you. Just to summarize, these are a couple of pitfalls I've pulled out. So not solving the right problems in your AI deployment means you're not going to get uptake, you're not going to solve things of value to the business or to your end users. And not giving the LLM the right information brings you to the technical limitations of these systems and reduces performance, reduces capabilities. If you want, there's a huge body of stuff out here on other pitfalls than the Nanda report's got loads. But our solution to this is twofold. One, you've got to start off by solving a real problem. We'd say solve a real problem for software engineers. They're under pressure all the time. There's never enough time for them to do anything. So why not attack the thing they spend most of their time doing, most of their technical work, which is understanding and debugging code? Secondly, tackle this problem of hallucination, which undermines confidence in LLMs, reduces their effectiveness, reduces people's trust and willingness to use them, for which we say capture a recording of your software, the software that you want the LLM to reason about, use that to ground the AI in the real world. Also, by the way, allow engineers to verify the facts that come out. So, I'm going to briefly summarize, for those of you who haven't come across us before, our approach to debugging by contrast with traditional debugging. So this is leaving agents and AI out of the picture for the moment and just talking about the core day-to-day work of how you solve problems in code. And the traditional approach is this top diagram. So you run the program, a bug's reported maybe by a user, maybe you find it yourself, maybe it comes from your test system, and then you go into this capture diagnostics and test hypotheses, or I might call the loop of sadness. So you can see here, you might use all sorts of tools, logging, thread dumps, debug builds, conventional debuggers, banging your head against the wall. It's actually quite a popular one. And you go around this loop many, many times because each time around you find some information that you needed and you didn't know you needed, and you have to go around again. Often also, problems in software are non-deterministic and they don't happen every time. And so you've got to keep repeating this loop until you've built up enough information. And at the end of the day, hopefully, you get enough information to understand the root cause. Generally, when you've root caused, a fix is fairly easy. And you solve the bug. Congratulations, everyone's happy. The other outcome, which is also valid and happens often, is this despair outcome. So we've heard again and again from customers that before they engaged with us, they had a lot of bugs that were just too hard or too finicky to solve, and they just had to go unfixed, or features needed to be disabled so the bugs couldn't be triggered. Not great, not satisfying as an engineer, and potentially leaving kind of booby traps in the code to jump out and surprise you and your users later on. The undo approach uses a time travel technology we've developed called the undo engine. And this allows us to capture everything that happens in a piece of software down to machine instruction granularity. So what that means is we can record a program while it's running and exhibiting a bug. And once you've captured that recording just once, you can replay it as many times as you want. Forwards and backwards, you can access any line of code that was executed, any memory location, any variable, at any point in time in the program's history. So all the information is available to you, and you're able to work forwards or backwards to figure out the exact causality. I think generally experienced users find working backwards is best because it gives you the chain of causal events that led to your problem. This brings us on to agentic debugging. And the concept of agentic debugging is that we provide these time travel recordings to an agentic AI, a coding agent. What we want to enable is for the AI to autonomously navigate what happened in your program for you. So this could be root causing issues for you, it could be working with you as a partner to understand a particularly troublesome issue, could be helping you understand and onboard in a code base. It could be that it's doing triage on overnight test failures and reports from users that a human will look at later. But in these cases, the recording is providing the means to explore the code in a directed way so it can pull the right things into its context window, rich information about the dynamic behavior of the program so that we have high quality context to draw on, and a ground truth. So the AI doesn't need to hallucinate because it knows what happened, and the developer doesn't need to trust the AI not to hallucinate because they can look in the record and they can verify the facts that the agent has pulled out for them. The goal in all of this is to get some real tangible business outcomes. So accelerate software delivery throughput and improve the stability of your code base. These are real things that the business cares about. Saving developer time and toil is something developers care about. These are real benefits from AI, which means unlike those other failed projects, you can get some real adoption. But with that, I would like to dig into a demo. What I'm going to show is first generation of our Agentic debug system. What we have here is our UDB debugger running in the terminal in the background, and it's loading our Agentic debugging extensions. And then we've got a frame viewer here, which is showing the current frame buffer contents from a recording of Doom. So I'm just going to set continue going so that you can see that we've captured an entire game here. A few weeks ago, I fired up Doom under Live Recorder, our deterministic recording tool, and I played a little game. And I went around, I fought some zombies, I collected some items, wandered through this spooky space base for a bit. I panicked at this point, hit the wrong key, and got trapped in the map for a while. That was scary because I could see the zombies were still after me. And then eventually, I decided I'd played enough, and I hit Control-C, ended my session. That is the end of our recording. What we've done here is we've actually replayed and reconstructed everything that happened within the Doom program whilst I was playing it. So we don't just have a video here, we have a complete record of all of the code execution and data involved in that playthrough. What I'd like to demonstrate is that by providing this access to an AI, we can answer human-type questions. So I'm going to ask, rather than setting breakpoints and stepping through the code and inspecting data, I'm going to ask explain, which is our AI integration command. When was the second zombie killed during this playthrough? So I'm asking this in natural language, but not only that, I'm asking a question about the behavior of the program rather than having to couch it in the implementation. First of all, what's going on here is we're firing up a coding agent, Claude Code in this case, but others work just as well. And it turns over control of the time travel debugger, UDB, so that the coding agent can actually drive it, move around in the recorded program history, and explore an attempt to answer our question. So first of all, it tries this variable total kills. Then it finds the players array and it tries this variable kill count. And what we're seeing here is the AI agent navigating through history based on the values of these variables. So it can skip directly to interesting changes in the data, which is often quite a good way to understand what a program's achieving. Because we've got a deterministic recording of the program, we've effectively got safety rails here. The AI can't disrupt a live debugging session that I'm doing. It can't mess up the state in the program. It can only review backwards and forwards through what's already happened and what's already been recorded. So we're providing here a ground truth for the AI coding agent to work with. We're seeing in the top right what was on the screen at the precise moment the coding agent is currently expecting. We can see here, it looks like it's found the second zombie kill in the game. So it's answered the main part of our question here. And what we're now seeing is the AI agent exploring some more state that relates to these points in time. It's free to travel back and forth between the points in time. It's found interesting, collect more information that it believes is going to help contextualize what it's found and provide us with a good, comprehensive explanation.
So here it's collected information about the second kill, and it's now revisiting the earlier bookmark it made at the first kill, and it's collecting contextual information for that. This capability to bookmark and return to an earlier interesting point in time gives it the ability to recover from failed investigation steps or to explore at its leisure anything that it thinks it might need to follow up later. We now have a summary, so we can see, based on our investigation here, it's got the time that the second zombie was killed in various units, it's got the location, it's confirmed that indeed this was a zombie type enemy, which is a MT possessed in the Doom code. It's also given us comparison of when the first zombie kill happened. This looks about right as well. It was about 1.4 seconds between the two because they're in the same room. And this is our answer. So we've been able to work backwards to a comprehensive explanation from just a recording and the help of our AI agent, and it's created bookmarks within the recording which we can use to verify the AI's reasoning or as a jump off for further investigation.